Donc il va nous présenter le projet de Fab City qui est en train de se monter actuellement sur Barcelone. Thomas est architecte, ça fait... et urbaniste, pardon. Ça fait 6 ans que le Fab Lab, un peu plus que Amélia, the Fab Lab. Ok, 5 ans. Donc, depuis 5 ans que le Fab Lab de Barcelone existe. Donc, je pense que tu as présenté aussi le projet Fab City. Et ça, je te donne la balle.
Thank you, Nicolas. Hello, everyone. Yes, I'm not an architect. I've studied urbanism, and it's mainly about cities. And I'm going to tell you some stories. Some of them might sound boring, but the main topic of the talk is to talk about this project, that is the Fab City project. And I also say this from microcontrollers to cities because I really want to go through projects that are from the scale that's something that fits into your hand to something that has wider, let's say, implications and impact, no? on the urban scale. So I'm going to start talking about cities and technology. Historically, one of the first cities recognized by studies is Ur in the Mesopotamia, in the antique Mesopotamia, 4,000 years more or less before the Christian era. So it was the first identification of a structure of a city as we know it today, of how we identify it. No? And the city organized around power. No? And this mainly was the basis probably for the Romans to develop a system of how they will open new cities. The growth of the Roman Empire was very much based on the cities and the structure of power. And each city has its own temples, the aqueduct, and all the structure of the carriages and the cumanos. So it was a formula in how cities should be funded, and basically the cities were, let's say, led by the power, no? In this case. So that's very funny because this formula was lately applied a few thousand years later by the discovery of the New World, and the Spanish and then all the English colonies and the French colonies going to the Americas, the newly discovered world. They were bringing with them, let's say, this formula of opening cities, and it really affected the rest of the world. No? So the same formula that the Romans were using to develop the Roman Empire was applied hundreds of years later in the discovery of the New World. It was in the 15th century. No? This is something very funny because in the same 15th century, Gutenberg invented the press. So it was also not only the formula that you can have to open new cities, but also the way in how you communicate that formula. It means how you spread knowledge. So basically that ability of spread knowledge was the basis, let's say it was concentrated in the medieval city, but was the basis of the Renaissance. No? So the big shift that happened in the development of the spread of the knowledge happened because in the 15th century Gutenberg invented the press. So it again changed the society, but maybe in the Renaissance the cities didn't change that much, and they were pretty much medieval cities with a lot of knowledge happening within the walls, no? And a lot of knowledge transmission, okay, inside and between cities. So what happened is like a few years later, or a few tens of years later, the steam machine was discovered in the 18th century, and it was the starting of what we know the first industrial revolution, you know, in which all the hand labor was started to be substituted by the machine itself. You know? So again, the mobility and the communications were based on the technology, and because the steam engine existed, so new means of transportation were invented, so we can transport, let's say, things like the train were invented, and then we can transport faster the knowledge between one place and another. No? So it was another big shift in how the cities were developed. And it was the starting point of industrial city, as we know from the books, or the concentration of population around the factories, maybe starting, as Neil said yesterday, in Manchester. No? So then in the beginning of the 20th century, we found a new, let's say, a new resource that is the oil, that in a way is a substitute of a steam in the production of energy. Okay. Then we started to produce things. Not only the hand labor was substituted by the machine, but also we started to produce the same things by many times. One of the clearest examples is the Henry Ford assembly chain of the cars, and this is very important because the cars were, let's say, by that moment is kind of the internet of today, because they started to develop a new way of structuring physically the cities. No? So it's even called Fordism. No? And also there's another thing related with knowledge is how the Bauhaus introduced the relationship between the arts, crafts, and industry. No? So it was a very interesting moment also again within a very short period of time that started to produce a new model of living and society. No? But also a lot of people don't talk about this, but again communications and how this knowledge would be spread is this Italian engineer Marconi in the late 19th century and the beginning of the 20th century invented the radio, basically, and the wireless communications. And by the end of the 19th century, they made the first communications between America and Europa, no? Transmit information wirelessly. So it was also another big shift and another big tool invented to transmit knowledge and furthermore transform the cities and societies. So the consequences of this is the car, for instance, developed the urban sprawl model as we know it today. So because we have private mobility, the cities can grow beyond the walls, let's say, no? and even further. We want to have houses with a garden, with a parking. So this has some implications. No? And of course, it was the originator of the modern city as we know it today. But then, in the middle of the 20th century, we started to invent other things that were more complicated. No? The computers, again, maybe I'm not talking too much about this, but this is the ENIAC around the 50s, one of the first computers that maybe fitted half of this room. Then the CNC machines, also in the 50s, and furthermore, the machines connected to the computers. And then, a few decades later, these computers became personal, and furthermore, we, let's say, discovered the internet. Or the internet was massified, no? Not only used by military reasons, but also by anyone. So those are another key moments of our history. And we would say, okay, if Gutenberg and the press and the Roman city model changed totally the way of living, and if Marconi and the Ford and the oil changed and also develop a new way of living, what have done internet, computers, and CNC machine for us so far? And that's, let's say, the formula that is not really fitting good here is this one, no? This variable in this formula, because we have this variable, we got to this. No? So we have a world that in which this globalization basically is based on the power structure, in which basically big companies that have access to technology are controlling what gets produced where and what is the value of that what. No? So the thing is that for this world to work, we need to have this huge means of transportation to put goods from one side to the other. We need to fill the supermarkets because we want different choices. We want to pick, the exactly thing that I want. And yeah, we want to, this is the modern, let's say, image of the, the perfect living, no? Perfect couple, good looking, go to the shop and they find everything. This is great. But the real thing is that what these people produce, or these people is we produce is trash. No? The main thing that we're producing right now is trash. And maybe Manuel, you don't answer this question, but how many of you have something that you made by yourselves with you? No? So that's something that I question myself everywhere, even myself, I don't have it. So, and that's contradictory. So we produce trash, that's the thing. And the things that bring us, these ships that bring us things to us, they drag, we have some other implications. But the more delicate ones is that this centralized model leads us to the control of those central resources, of either of energy, of production, and so on. You know? See what's happening with China, with the oil in the Middle East, and etc. So the energy and communications are very important to think about, and technology, to think about how we have been structured our societies in different times in the history. You know? I know that maybe I skipped a lot of things happening in between, but I'm trying to make it more simple. So I'm sorry for people that get more deep knowledge in history. So, but furthermore, that the other consequence is that we're having this weird mixture of local culture with this globalization. You know? And what I see that is pretty much compromising our future is how we are getting away from the knowledge, or production getting away from consumption means also that knowledge gets away from production. You know? What it means that we don't know how the things we have are being produced. It means that we don't have knowledge, we are losing knowledge, and the knowledge that we're getting is very speculative knowledge. It doesn't have any effect on our everyday life. So that's maybe the worst consequence, not maybe the oil spills that you can find, but one of the main consequences is this, no? Is how you not have the naive thinking of you are killing traditional cultures. No, I'm saying that we are misusing technology in one side of the world is trying to, you know, invade the other. You know, that this is the bad thing. So and later, and furthermore, this image of the David of Michelangelo, that man of the Renaissance, we are basically facing like this is our Renaissance today. You know, the McDonald's effect in our life, which it's pretty sad. It's pretty sad. I mean, again, it's not a matter of the looking, but it's a matter of what's in the brain. You know, what is more interesting in this image. So this is what we call the PITO model. Is the model that's product in, trash out. It means that you get the raw materials in Brazil or in South Africa, you send them to China, they are produced to a lot of, these big factory cities in which the workers are abused, as we all know, and then the goods are being shipped with those big ships or planes to the centers of consumption in Europe, or the Western world as we know today, that is not even the 20% of the world, and then we produce a lot of trash and we might send it actually to Africa again or to India. So it is in a way in a kind of perverted model with a lot of implications in socially, culturally, and also energetic and environmental. No? So the thing is that when we change these variables here, we again take the personal computers, we take the internet, and we take the distributed production. That is what we are discussing during the last days here through digital fabrication. Then we can have a different model that could be called the DIDO model. That it means data in and data out. So inside the cities we can produce raw materials, we can produce goods, produce objects, and even take the trash as a new raw material. And all the material cycle happens inside the city, but not only the material, but also the energy. It means that I will say it in a few minutes, but we are moving also in not only distributed production of things, but distributed production of energy, because otherwise this wouldn't make sense. No? So the thing is that we are going back in a way like a kind of medieval age. So imagine that we have the walls again of the city, but the thing is that you will be connected in real time with all the people through internet. No? So it means that the knowledge is globalized, but the other things that they don't have any meaning to globalize are still in a very local sphere, in the local level. No? So this happened, and as we all know, this is maybe the word most pronounced ever in the last 2 days, the Fab Labs. Maybe I shouldn't explain this, but this is leading us to what people is calling the third industrial revolution. So again, the steam machine in Manchester in the 18th and 19th century were leading the first industrial revolution. The Ford diesel and the chain production in the beginning of the 20th century, powered by the oil, was the second industrial revolution. It seems that we are facing towards the third industrial revolution that is pretty much supported by digital fabrication and pretty much supported by distributed production of energy. This is something that Jeremy Rifkin, he's one of He's consultant for the European Union of the development of a new economical and energy model for the next 20 years. And basically, in his book, in the Third Industrial Revolution, what is really funny is that he's focused only in the energy issues, no? In how energy issues, if we produce energy in a distributed way, the power, the relations, and everything will be restructured. No? He talks about the lateral power, for instance. But what's really funny is that he barely mentions digital fabrication. And if you look for Jeremy Rifkin's last talks, he's saying that if you should note about something that is very key, that is going to change the future. I'm blaming Jeremy Rifkin, and he said, and it's 3D printing. So he got the point. He notes that something is happening. Maybe he got only the microwave, as Neil was saying yesterday. But he got the point that distributed production of goods will also change the power structure. It's a basic variable in this third industrial revolution. So again, we have the Roman city, we have the industrial city, the medieval city, the caral city, the modern city, and now everyone is talking about the smart city and how technology is going to lead us to a better world. And we have super efficient, no driver cars, and intelligent electric lights, and then the lights of the plaza will turn on and off according to where it's passing. So what the fuck with that? No, so it doesn't matter. I mean, the thing is that we are not really changing anything. We're creating new businesses for IBM, for Cisco, and for the governments, and that's it. No? That's a very key thing. So the real question is how internet and distributed production would really affect the next model of cities. No? If the car produces the cities as we know it today, as the structure, basically the streets are defining how our cities are, is physically defining, but the streets exist because the car exists. So what happens when you don't have to move that much as we have to do it before? When you can work from your house, where you can produce the things just in the next door, and you can do supermarket, you can go to the supermarket through a website. No? So we are reducing a lot of mobility, and we are maybe creating a more complex layer of mobility. So these are questions still that we don't know how they are going to be answered, but for sure is something that is going to change the cities of the future. So I'm going to drive, because I get deeper into the Fab City, I'm going to talk about some of the projects that we have developed in our Fab, in our Fab Lab in the last years. And they're basically going through different scales. No? I mean, from a microcontroller scale, maybe this is the smallest microcontroller that you can make in a Fab Lab. It's just a hello board that you can connect to your computer and make to display a message in the screen. It's a very basic one. But you can start to make the more complex projects. I'm going to talk later on about one complex one about data capturing and sensing. But this is like, for instance, like an artificial fruit that you can put in a tree and then monitor how the tree is behaving in real time. No? So you can know how much water it needs, or if it's exposed to contamination, and so on. No? So then you can go to a bigger scale and work with the materials. No? The materials itself, the development of the materials is something key, and we were talking yesterday, how you can use new materials for the production of things. And this is basically a 3D printer that is a little bit bigger than a MakerBot, and it's using as a material clay, clay that you can naturally produce it. And I will show you a video of how it looks like moving, because the machine is very sexy, so it's nice to see. So basically the students were using the machine framework and developing an extruder of material. That's it. These machines usually are used for the car industry. These are the KUKA robots, the 6-axis robot. And you can do things as big as this, no? But if you put this extruder, but if you put a bigger extruder and you use concrete, you can print bigger structures and even the houses. No? So this is some software simulations. This was developed in the Masters in Architecture in the Institute by architects, by students that they were playing architects programmers, material scientists, and so on. This is some geometry explorations. It's really sexy, hypnotizing. It's like machine pornography, basically, to watch this robot moving. Huh? So there are other projects. There's, for instance, a Dutch artist that is making furniture with the same robot by melting recycled plastics coming from fridges. No? So it's something that you can achieve different scales of working. So of course they will have to think in all the materiality, but also the implications, no? And trying to think how robots can work in a coordinated way. If they work together to make cars, they can work together to make buildings as well. No? And yeah, then another jet project is the very well-known Fab Lab House. We have explained that like I don't know how many times. I'm going to skip it, but I'm going to talk about this next iteration of a solar house. That is this Endesa Pavilion. We did it for the Smart City Expo in Barcelona. And Endesa is one of the big companies of electricity, and they basically commissioned us to make this kind of structure. It's like 120 square meters, designed it and developed it in the Fab Lab. In this case, some of the bigger panels, we have to produce it in a company of wood near us, but basically they have a CNC machine. And I'm going to show you another video that is this pavilion, which looks nice. It's in the best hot spot in Barcelona, next to the sea. And basically, it's, again, full of solar panels that can produce twice the energy that it needs. And basically what we're doing here is making a simulator of the Smart City project by Endesa. So the difference between this in the previous house is that this one can grow vertically. The Fab Lab House cannot do it. So that's one of the main concepts of this one. You see these different modules stacked together, all the interior produced in the Fab Lab as well. And yeah, they organize meetings. And you see, one of their projects is to have an electric bike. The house is attached to a charger of cars also. So it's a whole setup of not only the physical space itself, but also the technology behind what would be the smart cities and how the distributed production of energy can lead to a more complicated or more complex relationships. No? Yeah. So then another project that we developed back in 2008 is the hyperhabitat installation, and this goes to, I don't know in which scale to put this. No? See, if we're going in these scales leading to buildings, this one was called hyperhabitat reprogramming the world. So we made an installation. I think Rodolfo showed it this morning, and we made an installation in the Fab Lab that was going to be produced. I mean, it needs to be in the Venice Biennale in 2008. And it had to fill like 300 square meters. So we made a whole acrylic installation of 6 apartments. It's a simulation of six apartments with shared spaces. And each one of the devices of the apartments, think about like I don't know, the kitchen, a skateboard, or a bed, or a table. Each one of the objects of the house had internet serial number. It has a little server that could send information to the other. So the idea was how we can think on the intelligence embedded into the objects, and how this is not that one object is super intelligence, is how a lot of objects connected can generate more complicated intelligence. No? So it was the electronic boards developed in the Fab Lab, and then we had to produce it in another place. We produced it in the US, I think, because we didn't have time basically to have like 150 nodes, or really little electronic boards. And the concept behind this is mainly related with the energy efficiency in buildings. Is how you can save energy in buildings by having intelligence embedded in each one of the devices of the building related with energy. It means that instead to have big savings of energy, you don't need to have like to turn off the building once at a time. But if you have little savings, and then you make your air conditioner to talk to your windows, and your doors to talk with your lights, and so on, you start to have like little savings, and when you sum all up together, it's a lot of savings. No? So it's called the long ring tail, this concept. So again, we produced in the Fab Lab. This is the big laser machine we have. These are the sheets of plywood being cutted, and then we put it in a van, and we drove to Venice. We took the things, we installed, we put the installation together. We make it work more or less, let's say. The network was not very stable. We developed this with the Center for Bits and Atoms with MIT, and we had part of a team working there and so on, but it was like the first time that the Internet Zero protocol was tested in this scale. So we had a lot of problems, but we succeed, I can tell. And then this is to close a little bit about the project, no? how we arrived to cities. Basically, this is, of course, the Fab City project. If you think about all the steps I've been going through in the explanation of cities, we again have those steps shown in Barcelona. No? The Roman city, the medieval city, the industrial city, the modern city, but tomorrow we don't know yet. No? Right now, the Barcelona of today, the modern city of Barcelona, is a city of a spectacle. No? Everyone goes to Barcelona to have fun. The British go to the Rambla to have cheap beers, and you can have, I don't know, in one single street. Well, it's a disaster. I won't say anything else. But the thing is how the city could become again productive. No? And this is one of the main things of the Barcelona 5.0 project that we are thinking. To give you a little bit of background, I've shown you until now the projects that I showed you are part of IAC, the Institute for Advanced Architecture of Catalonia, which was funded by Vicente Guallard and Willy Muller. Now Vicente Guallard is the chief architect of a city, and Willy Muller is chief of one of the biggest agencies of urbanism in the city. So most of these ideas that we have been maturing inside IAC are reaching now a different scale. Some of them are reaching a bigger scale in the city of Barcelona. And of course, the Fab City is a consequence of that, of these years of working together with MIT and with all the Fab Lab network. So the thing is that how we can think about is again, we don't think that globalization is wrong. What we think is that maybe it got the wrong scale. So how you can think on things produced in one side of the city, and then you have a specialization of each neighborhood. As the Chinese do electronics, how you can have like one district of Toulouse making electronics, and the other district making things related with design, another district making things related with healthcare and prosthetics. So the thing is that how we take the same idea of the globalization and we put it in a scale that is not compromising on other resources, as energy, for instance, and in a scale more important that keeps the connection of knowledge with production, with consumption. Again, in a scale in which we can control the iterations of a design, of a prototype, of an idea, or whatever, or a product that is satisfying the local needs, and that local needs satisfied are feeding knowledge that is being generated. So that's the thing. This is how we scale down, and globalization is one of the main ideas of the Fab City project. So we said in Lima back in 2011 that this was our plan for the future, and that in 2012 we were opening 4 new labs besides the one that we have already working in Barcelona, in this district of Poblenou. But the real idea is to put 1 Fab Lab per district, but furthermore 1 Fab Lab per neighborhood. We have 10 districts, but we might have it's like 84 neighborhoods in Barcelona. So how we can achieve this? Our model is based on 4. Well, right now it's a model evolving, I have to say. But right now we can say that this is based on how we can generate new skills and production and education methods. No? That goes together. If we produce in a different way, we need new skills for people to learn how to produce in a different way. You know? So that's one of the big gaps that we have now. How these new production methods can generate urban renovation and innovation faster. It means that solving the city needs faster. How we can think about the neighborhoods as a productive hubs in the city. I was explaining before, a productive hub of electronics or design or whatever, and they can work as a metropolitan network in a way not totally synchronized, but at least harmonized together, as the Fab Lab network kind of does. So the replanning is that in 2013 we might have 3 or 4 Fab Labs. I can tell that between this year ends, we will have the Fab Lab in Las Corts open, in the Fab Lab in Baidaura open. In the 4th of December, we might have a big event in Baidaura. We will send you invites. And the next year, we will have the Ciudad de Barcelona Fab Lab that is now under construction, and probably a couple more that are still in conversations and I cannot show you because this is pre-recorded. So this is one of the Fab Labs in Las Corts. It's one of the richest neighborhoods in Barcelona, and it's inside an old glass factory where there is something of a library. What is really beautiful about this project is that a library is going to come in this space, but the new libraries of the 23rd century, they don't only have books, they don't only have computers, but now they have a Fab Lab inside. So it's another way of thinking the new tools that the people need to get access. No? So remember that maybe in the 90s all the libraries were introducing computers and it was like such a major change in the traditional libraries, but now we're ready to the next one, is to introduce digital fabrication tools in the maybe almost obsolete libraries. So this is the other Fab Lab in the other side of Barcelona, in Ciutat Meridiana. It's one of the, let's say, almost a suburb of Barcelona with a lot of problems and social problems and so on. It's inside a disadvantaged people's school. It's like a school for disadvantaged children, which is a double challenge. And we have a lot of space. No? So if you see, both of them is a lot of space, but it's like a between 600 and 800 square meters. So the thing is that within these Fab Labs, we don't only have a Fab Lab, but we will have other initiatives, existing companies, projects, and so on. And one of the projects that we're going to put in this one is a project called WikiSpeed. I don't know if some of you know it, but it's a project that is being developed in the US. It's how to make a low-cost, efficient, fast to build car. You know, it's how to start to think that the Fab Labs can produce cars, bikes, skateboards, in musical instruments. You're doing, but this is what I was asking, not how you can optimize the production times in order to reach, maybe not get to industrialize it, but get a little bit, speed it a little bit more. So, and another one that is really one of the challenges is the Green Fab Lab that is within like a forest it's like 10 minutes from the city center of Barcelona. And basically, this Fab Lab, what it's going to do is relate nature with technology, with a lot of loads of humanism, no? Like with society. So the idea here in this Fab Lab is that we want to produce locally the energy, we want to produce locally the goods or objects, and we want to produce locally the food. So if you think about how we were, like, I don't know, maybe 6,000 years ago or 10,000 years ago, we only needed food, energy, and fire. The cavemen were doing hunting to get food, they were making fire to get warmer or whatever, and they were making the tools to hunt or so on. So that's the same idea, how we can be back again cavemen, but with different kind of tools, and get reconnected with the nature in a different manner. So this Fab Lab would try to use, of course, different kind of materials, try to extract from the same woods the materials that we are using to produce. So we might be thinking think about, I don't know, like a wood 3D printer, think about natural resins coming out directly from the natural processes of the forest, how we can develop tools to monitorize the forest itself, and so on. No? So this is also linked with we will have a Fab Lab, but also we will have facilities to produce energy. We are developing with the same company, the DESA company. We're developing here the project Energrid, that basically is what will be one of the demonstrators of the future Internet of Energy. Okay, so this is very linked with what I was saying before, how we can distribute and manage, how we can produce and manage in a distributed way energy will also affect the way we are living. Jeremy Rifkin says very clearly. And then, of course, we will have orchards and food production locally, and some animals to kill them and eat. So the thing is that how do you think this should be managed? How do you can imagine the Fab City is going to be developed? No? Since we have the big support from the City Hall of Barcelona, this might be like the traditional way of approach. The City Hall come and say, yeah, we want to open a network of Fab Labs, we're going to control them all, and we are just going to say what it's going to do each one of them. So this is wrong, because there are a lot of complexities that maybe a City Hall understands this, but the thing is that the City Hall can understand these kind of things, but in a separated way, in an atomized way. So it means that all these things are separated within a city organization right now today, in the administrative level. So if you want to do something related with services and businesses, you need to go to two different offices. So it will screw up. It will screw the model itself, because I don't know if this defines the Fab Labs, but maybe something that put some variables that are all of them inside what we call is a Fab Lab today. Now, it has all these different implications that are not only technical, but also the social, the economical, and so on, also the educational. No? So what we think it will be more like a network that they will only be Fab Labs. But the Fab City will link also other initiatives like makerspaces, tech shops, and so on, and alike. For instance, in Barcelona, there are things like Makers of Barcelona, or more complicated organizations that are already making things and innovating in the fields of digital fabrication and do-it-yourself and hackerism and doing with others. So it doesn't make sense to act as an island on an already existing movement, no? that we are facing today. So the other thing that we need to source is besides the organizational, that this gives a hint. We don't want to have like a very top-to-bottom approach and say, the Fab Lab should do this and this and this. I think each Fab Lab will do what it needs to do. Each Fab Lab will have a different link with the city, and it will respond to its reality. No? But besides that, we will need to work also in who is the people that is going to be behind it. I think that we cover pretty much the technical level. We control the machines. We are the processes are pretty much being achieved more faster and so on. But it's very key on this model is how you train the people. No? So for instance, Nerea, who is sitting here, was part of the first scholarships that we did for candidates to run one of the Fab Labs in the Fab City project. No? So that's very important. Is how you get, before you open a Fab Lab, get the people that is going to run it. And I'm not only saying to the Fab City level, but also in general, for all of you that are interested in developing Fab Labs, the people behind it, and you can tell it also, Alex, is like the key thing. It's the people that is going to be feeding day by day the energy of the place. It will be the connector with the people that is coming to use the Fab Lab. So you want to be really, really, really aware of that. So we have a program that is called the Fab Academy. This is the official first graduation, Alex, no? Back in Amsterdam in the Fab 6 conference. And basically, Neil was talking about it yesterday. We invented this model on having each Fab Lab as a classroom, and the campus is the planet, and the means to get connected is the video conferencing system in internet. No? So this is one of our golden projects for the future. We are evolving in the idea that this could be a university that has a 5-year plan, that would have a PhD programs and so on. Then that's the thing, no? You get the technical training, you get the academic training, so you get technology, the education on academic level. But we need to create impact, no? And then one of the most challenging ones are economical, as you were saying also before, and we're starting to see some hints about it, no? Of course, we cannot think about like the traditional incubators of projects in which we are going to generate a traditional business and people will be rich and blah, blah, blah. I think this was part of a discussion panels in the previous days. But how you can take advantage of the knowledge that is being generated in the labs and look for alternatives that is not only going to a bank or going to a guy with a suit, and just by yourself start to create projects that could have impact. No? So one of the clear ones is, and of course everybody knows about it, is crowdfunding. No? Is how you can either take a project developed by a student in the Fab Academy or someone that just came to prototype something and think about how it could generate an added value. And this is one of the first successful crowdfunding campaigns we had, and it was about shoes. And the shoes, they don't look very comfortable, but and maybe they don't, I don't know, they are the best designed tools, and then maybe the Italians would laugh about it and say they are crappy shoes. But a lot of people wanted to have their own shoes that will self-fabricated and let's say in a way like, you know, they were being like a manifesto itself. So that's also another thing. I think that people is looking for a different set of values that is not only to consume or get the most massive shoes. At least we hope that is happening. No? So in relation with that, in the crowdfunding, I'm going to link it with a project we just are about to send to production. We have the Smart Citizen project, and it's a project about citizen-based data production. Is kind of the contraposition to the smart cities models, as I was saying before. Sorry, the smart city model is how IBM and Cisco or these big companies are linking with city halls to make big businesses of infrastructure and so on, and I don't know, it could generate a lot of revenue. The thing is that in order to do a lot of things that the smart cities projects are saying, you don't need more than the existing internet infrastructure that the people has today in their houses, and just another link. The one another link was missing, is what we think. So why? The thing is that we thought, why do we don't go to a crowdfunding platform again to make a project that is citizen-based, no? Because it's data produced by citizens, and the idea was to think about what about if each house or each person is a node on this network of data. This data was mainly about environmental conditions. So we developed this kind of prototype of an Arduino shield with Agar with the Fab Lab. And we're using different pieces. Now we have the Arduino, and then we have this module that is the Wi-Fi module, then of course the battery and all the 5 sensors, and then all these components in an Arduino. And for the shield of Arduino. So we got this to this. So this is all together in one single board. This is the Wi-Fi antenna, this is the microcontroller of Arduino, it's based on Arduino Leonardo, and it will look like this. This is a render before we're sending it to production, and on top of that we put a shield, okay, in which we have the humidity sensor, we have the NO2 sensor, the CO sensor, and sound sensor. Then we have light and temperature sensors, but also we will use the solar panel as a sensor. We will use also the Wi-Fi antenna as a sensor, knowing how much radiation are you exposed surrounding you. And of course we will monitor the battery itself. So the idea behind this project is you just have your infrastructure that is internet, and mostly everyone has internet in their house or your neighbor. You put the password of your internet, and automatically these sensors start to upload data to the web. But where? To a platform that we are also developing. That it will be a platform that's based on geolocation, in which people can look what their neighbors are producing and so on. I will show you the beta version of the platform. Of course, it's missing a lot of functionalities, but it's how it would look like. No? See, this is right now. I mean, this is based on OpenStreetMaps. You can go to different neighborhoods of Barcelona and see which kind of information it will produce. This is in terms of temperature. Okay? okay? But still, this is, again, this is based on other data produced by whoever. We're just taking information from COSM or Pachubet, and what we're doing is just taking random data. And this is one of the issues we have, that you can have one guy, not with our sensors, with their own sensors. You have someone that is producing 46 degrees in Barcelona, maybe they have it, I don't know where, and then you have another one that has 12 degrees. So it is kind of the tools, there is a lack of tools still that for anyone everywhere to start to produce data. So this is why we developed this platform, or this both hardware and software platform, because you will have this sensor, and literally you can have the both ends. You can have someone that doesn't want to deal with coding and so on, and just plug the sensor and automatically it will start to upload data. Or you can have someone that you can use like extra capabilities and maybe put in a GPS antenna and put it in a bike or whatever, no? Or put more sensors. Actually, one of the next implementation is to put a energy metering sensor, no? Which makes a lot of sense. So the thing is that, yes, this socialize the data in a way and also humanize it, no? How to make it more understandable, how to start to generate maps that we understand and they are more linked with the common tools that we are using. I was saying today that I think that the internet, the 4.0 internet, will be the internet of the maps, because we will be, everything that we are going to relate with, it will be based on maps, where I can find what I'm looking in the internet, how near it is from me. No? And another metaphor that I like to use, that we have all this cloud content and all this information that is flying around everywhere. No? You see, yeah, we are surrounded by the cloud, but when it rains, it doesn't rain in front of my house. No? So how we make this cloud to really rain on top of us in a good way. I hope that it's not acid rain. So also in relation with not only with data, with objects, we are trying to also think about more complex relationships that goes to the different, let's say, processes on generating an idea and taking it to market. No? In the IKEA model, maybe the designer makes a design, then it gets approved, then it goes to fabrication, then it goes to the store, and then it goes to the end user. It uses and then it trashes. No? That's what's happening. Then he forgets about the relationship with the object. He doesn't know about the object itself. So we are trying to develop the Fab products or the Fab design project is basically how you can have the iterative design. It's pretty much related with the open design as well. It could be linked. But the idea is that the design never finishes. And also maybe the user and the producer is the same person, and the designer. So it started to create like a more complex relationships. And not only that, it's also that how, let's say, a shelf could be tomorrow a chair, and then the chair tomorrow could be a box where I put my pencils. No? So how we can iterate the design, and I will tell you how. If you think about the cycle, you extract the wood, you produce it, you put it in the factory, you sell it, and then you buy it, you put it in your house, and then you throw it away. No? So what if this can be linked here? No? So how this can go here, and then we skip this step. In some cases, not all of the cases. No? We're not saying it's complementary. So one of the things that in Barcelona, each neighborhood has its own day in which people take out like big things. It says when you want to change your own bed, you have, my neighborhood I think is on Tuesdays, so you can put outside in the sidewalk, as you see here, like big chunks of materials. And what is funny is that before the city hall comes to pick it up, there come people like I don't know, with the trucks, and they start to take the things that they are interested in, no? Like, I don't know, mattresses and so on. Okay, so it has a kind of organization, no? It works like in each one of the neighborhoods, it has a different day. So the thing is, how would you think about like distributed facilities, no? In a scale of the neighborhood, again, linked with Fab Labs, in which you can take your own all things, bring it there, you make an inventory, and then you know which kind of raw materials you have accessible to develop an idea. No? And in this sense, it's something that we're working pretty much with the designers, the service designers, no? That how we can generate another relationship with the objects, and how you can generate further life for objects, no? Life after life. So that's also one of the ideas, not only in terms of big chunks of wood, but actually how you can think about electronics, no? That can, basically in this project what we did is to take an old vacuum machine and then convert it into a fan. No? Or you can convert it into a mini turbine energy generator. No? So in a way, it might sound naive, no? It might sound just an exploration, but really, if we think that we were talking, someone was asking yesterday about the program obsolescence, is that how we can program the objects that when they get one of their function finishes, can get another function. It can be related with other things with value. No? So that's something that we're pretty much interested in. We are, again, developing this, this project was called Amplify, that we developed with a student of the Umea Institute of Design in Sweden. And it's really to start to offer these kind of higher level services, no? That more linked with